Making accurate power integrity measurements continues to increase in importance. As rail voltages get smaller and tolerances get tighter, measurement noise makes it difficult to get accurate ripple and noise values. Quickly determining if there's coupled sources on the power rail can be problematic. To address these challenges, Rohde & Schwarz has developed a probe uniquely designed for accurately and quickly measuring power rails. Some key specs include a 1-to-1 attenuation ratio for low noise, built-in offset of plus or minus 60 volts to support a wide range of rail standards, and 50 kiloohm DC input impedance to minimize loading. Let's take a quick look at the probe. For quickly taking preliminary measurements, use the browser. It has a number of accessories. The ground spring minimizes ground loop area for best measurement. For more accurate measurements, there's an SMA cable that can be attached to the active probe head. At the end of the SMA cable, I've soldered on a 50 ohm coax pigtail for best quality measurements. Today I'm using an RTE bench oscilloscope with 2 GHz bandwidth. The probe, when plugged in, has an incredibly useful feature called a probe meter, which is essentially an integrated DC meter in it. I'm going to go ahead and turn it on. One of the very nice things about the probe meter is it gives me an accurate DC readout, even if the signal is off screen. And it gives me a hint of what offset value I need to type in order to bring the signal onto the center of the screen. I now have my power rail. If we look at the bottom, there's a peak-to-peak measurement. It's a very, very small rail with only about 15 millivolts of amplitude. Most solutions can't make this measurement because of excessive probe and scope noise. We make a good one because we're using the specialized power rail and a scope that has low noise. Power integrity measurements often require longer time captures with fast sample rates. Here we can see that we're using 10 megasamples of memory. Notice that the scope stays responsive. With electronic PCB miniaturization, coupling of nearby sources on the power rail, such as fast clocks or other signals, present a higher risk. If we turn on an FFT, we can get a quick view of what other sources might be coupled. Here I can see a little 2.4 gigahertz Wi-Fi that has signal that has been coupled onto the power rail. The amplitude won't be exact as it's close to the typical 3 dB point for the probe and the scope. It's still useful for a quick confirmation that there's a coupling issue. In summary, if you are making power integrity measurements, give Rohde & Schwarz oscilloscopes a serious look. The scopes with the power rail probe will help you make fast and accurate measurements. Thanks for your time.